No. We should not go for the root cause, the RCA and all. We need to fix this first. We need to roll back to the previous version. Then you need to make your application up and
I'm
run.
sharing my
Then you
screen.
switch to
So
your
let me
root
know
cause,
once
the
you guys
debug
are able
part.
to see my screen.
Because we should maintain the infra to be up and running always, right? We should immediately we do the
Is my
rollback.
screen visible?
And how do we roll back?
Yes,
We do
sir.
have a command called
Okay.
kubectl rollout
Let's
status.
have a discussion
Right?
on
So
services.
we'll have to
Services
roll
in
back to
Kubernetes.
the
So
older
till now
version
we
or
have
maybe the
discussed
new.
about the deployment and the pod namespaces and the pod, right? Pod is here. Yes, right. And now let's have a understanding of services. Okay. So what is this services that we use, and what is the benefit of services in Kubernetes that we wanted to use, right? So as I said, services. So this defines the logical set of pods. See, logical set of pods in the sense the replica of pod, right? So based on the services that we're gonna use, that is used to expose the application from inside the cluster to outside the cluster, so-called services. Say suppose, let's take an example of our any application, WhatsApp. Let's take an example of WhatsApp. Nowadays we are using WhatsApp like anything, right? So now that application, when we built, when we have configured every everything in the cluster, within the cluster, that we need to expose it to web, right? So we can also use WhatsApp in web, right? And similarly we can also have the WhatsApp application. Means we are exposing, once we built application within the cluster, we exposed it to outside the cluster. So whatever the application that we built, we have to make use of that application in web. We have to make available in web also. That's how we do the application to, because how do we do the exposed application, right? Once we have the application built with the technology, that's how we use the services in Kubernetes to expose our application from inside the cluster to outside the cluster. Okay, so I'll give a definition. This defines the logical set of pods. So which is used to expose, the application from inside the cluster to outside the cluster, right? So we do have cluster components. The complete control plane we call it as cluster, correct, right? So the cluster that we have, control plane has the node component and the control plane component called API, uh, kube API, kube HCD, right? And kube control manager, and what is one more?
ETCM.
Kube HCD, right?
Yes.
So those complete control plane and the node component called cluster, right? So that cluster, we expose our application from inside the cluster to outside the cluster. That's why we use the services. Okay. Now there are four types of services in Kubernetes. Four types of services in the Kubernetes services. Okay. So there are four types of services. Okay, so let's list what are those. So the very first, cluster IP. Okay, cluster IP. Okay, and the second one, node port. Okay, and then third one, load balancer. See, this load balancer is different, and whatever that we configure in your cloud component, that load balancer is different. Okay, so this load balancer is related to the Kubernetes service. And then fourth one is external name. Okay, so these are all the four types of services that we gonna make use of. The services used to expose the application from inside the cluster to outside the cluster. Okay, now let's learn one by one. The very first, which is cluster IP. So what is this cluster IP and why do we use this and what this represents? Okay, so the cluster IP is a default service in the Kubernetes, which means, so when you create a service, so if you're not defined also, so it will be the default service in Kubernetes. Okay, so which exposes the service and internally, means exposes in the sense we are able to access the service within the cluster. Okay, so this makes the services accessible within the cluster. Means once we build, say suppose till today we have implemented Nginx, right? Nginx is a containerized application. So through that we are able to log in to that application. We can check the logs inside the cluster by making use of cluster IP. Okay, so it is a default service, in Kubernetes, which exposes the service and on internal IP. Okay, so once we create a cluster IP, so we will have a IP called internal IP. Through that, we are able to access the application within the cluster. Okay, so this makes the service accessible within the cluster. Okay, so for example, so how do we write? It looks type. So we use type as cluster IP this way. Okay, so so when we start writing a YAML, you will see this, the type that we use as cluster IP. Okay, so this is we gonna use type as cluster IP to expose our application within the cluster. Okay, so the cluster IP is basically, it is a default service in Kubernetes, so which exposes the services and an internal IP. Okay, as soon as you write type as cluster IP in your YAML configuration, so it will create the cluster IP service for a particular application, and this makes the service accessible within the cluster. That's how we use the cluster IP.
C should be capital, sir.
No. It should be. It's not like capital small. It either when you start writing your AML, you can write either small or capital, but it should be in a small. And
Okay.
IP should be should be in capital.
Okay, sir.
Okay. The second one that we have node port. Okay. And here, so this explains, this uses a node port is basically, uh, this is also one of the service that the node port has the node IP. So whenever we use type as node port instead of cluster IP from the Kubernetes component, so that exposes a service and node port. Okay, so node port service itself helps to expose the application via the node port. Okay, and the same node IP and the port number that we use to expose our application from inside the cluster to outside the cluster. Okay, and the node port range from 0 to 200. Okay, so this is basically, so this node port is basically which helps to expose an application from inside the cluster to outside the cluster via the node port, right? So every node has their own port, right? Correct, right? So for example, we do have a node port of SSH 22. We are connecting remotely via the port called 22, right? So that's how when we use type as node port, it automatically creates a node port and the IP, uh, node and the port. So via that application, we can access application via the node port. That's how it defines. Okay. So exposes the service on and node port and the same node. Okay, and the same node IP and the port number that we use, same node and the port number that we use. Okay, same number than the port that we use to expose the application from inside the cluster to outside the cluster. Okay, so node port is basically expose the service to an node port and the same node IP and the port number that we use to expose the application from inside the cluster to outside the cluster, right? So this is also a one of the service. So it has the node port and then IP. Okay, we use the same IP to expose our application. Okay, for example, when we use type node port, okay, so we use the service this way. When we use the service node port, so uh, it looks this way. Okay, so the node port, okay, and then colon port number. Okay, port number. So how do we expose? Say suppose if your node port, node IP, sorry, if your node IP, this should be node IP. Okay, suppose if your node IP say like 5.6.7.9, right, colon followed by the port 8080. You getting this? Through this, we're able to access this. We already did in Jenkins, correct? Correct, right?
Yes, sir.
That we are making use of one of the service called node port. Through that, we are exposing our application via the node port. Type as node port. Okay. So the node IP followed by the port number. Okay. So this we have to expose our application. This we have to write it in a YAML configuration. So in Jenkins, we are configuring in our security groups, correct? We are going to AWS security groups and we are enabling it, and then we are exposing Jenkins in the web. Okay. Now in the Kubernetes, there is a concept called the port. The service called node port. This helps us to expose our application from inside the cluster to outside. Getting clear? The third service, you guys are with me?
Yes, sir.
Okay.
Yes, sir.
Third service, that is load balancer. Okay. So what is this load balancer? Okay. So load balancer is one of the service. Obviously, we know that from Kubernetes. So this helps to create an external load. Uh, I mean, external load balancer in the existing cloud. Okay. So this helps. This helps to create an external load balancer in the existing cloud. Okay. So load balancer is basically, see, you will say it is one of the service from Kubernetes services. This helps to create an external load balancer in the existing cloud. Say suppose when you are using cloud as AWS, it will create a external load balancer from our YAML configuration from the Kubernetes in the existing cloud. Means existing in the sense, suppose if you're using AWS, it will create a load balancer within the cluster. And suppose if you're using Azure, it will create a existing external load balancer in the external cloud. In the existing cloud, which you are using either AWS or Azure or GCP. Okay. Now, how it looks. For example, if I use type as load balancer. So if I use type as load balancer, so we will be able to access the application via, so what is the IP above? 5.6.7.9, correct? So this here, when we use the load balancer, we no need to point to the node port to be access the application. We can directly use the load balancer IP, which creates an external, which creates an IP. Through that IP, we're able to access it. That's it. We no need to use the port number when we use the type as load balancer. Okay, so load balancer will helps to create an external load balancer in the existing cloud. Okay, so this is how we define the load balancer as a type in the YAML configuration. This is basically, see, you can also add the statement, whatever the service you are using, you can say that all the services that we use in Kubernetes, which exposes the application from inside the cluster to outside the cluster. Okay, so similarly, we do have cluster IP, node port, and load balancer, but that statement is common for all four. And based on that, you can add when they're asking load balancer or when you are working on load balancer. Okay, so this helps to create an external load balancer in the existing cloud. on top of this statement. Okay, so this you can match with all the services. Okay, the fourth one, external name, right? The fourth service, external name. Okay, so what is this external name? So external name is basically, so this maps the services to the contents of the application from inside the cluster to outside the cluster. Okay, so basically when we implement any application, so we will be having the dedicated domains, right? See suppose when WhatsApp, uh, before, whenever we were not using WhatsApp, right? So we used to do the normal messages. We used to send the normal messages, right? So when WhatsApp came into picture, they have built the dedicated domain for a particular application. Say like www.whatsappwebapp, right? .com. Similarly, each and every application when you are planning to build, when you are planning to have the own application is built, it should be having the dedicated websites, the domain, so-called external name. Okay, so it maps the services to the uh, contents of an application from inside the cluster to outside the cluster. Okay, so basically when we're using any application in web, so that will be having dedicated domain, so that we have to make use of that. So through that, so we do have the external name. So you're getting my point, right? So the external name is basically when we have the dedicated domain, dedicated website, right? Guys, just a minute. I'm getting a call. Give me a minute, please. Okay, sorry. So external name is basically, yeah. So as I said, so external name is basically access the application via the uh, domain, the DNS, Kubernetes DNS, which helps to expose our application through the DNS. So as I said, WhatsApp, we can also have the website, and also we do have the application. That website is built with external name from the service of Kubernetes called external name. Okay, so I'll give a statement here. So an external name refers to uh, a way of a way to expose an external service. Okay, basically external service in the sense outside the cluster. Okay, cluster outside the cluster using the Kubernetes DNS. Okay, so this is achieved through the external name as service type. As service type. Okay, so basically external name is a kind of special service. Okay, so external name, we have to write the type service as external name this way only. External name is a special Kubernetes service. Okay, service type that lets the application define the Kubernetes service which maps to an which maps to an external DNS name. Okay, so external DNS name without creating, this is very important, without creating a traditional Kubernetes service, that is no IP, okay, no proxy. Okay, so without creating any IP, without creating any proxy, we can have the application to be accessible via the service type as external name. Okay, now how it looks and what is the making use of this external name as type service. Okay, so I'll just give a brief example here. So how it looks and what do we make use of that as a external name as service type. Okay, so for example, we all know we have the 4 parameters in all the YAML configuration, correct? So the very first API version, the second one kind, third one metadata, fourth one is spec. So as I said, API version represents the version of the Kubernetes, and the second kind, the services kind that you want to use. Either when you want to create a pod, you will mention under kind as pod. Whenever you are creating a deployment, you will mention kind as deployment. Whenever you're creating a namespaces, you will mention kind as namespaces. Okay, and also I forgot to inform the namespaces we can create via the YAML also. We can create the namespace via the command line also, kubectl commands, correct? So when you want to create a namespace, we use the kubectl get create ns, correct? It will create a namespace in the whatever the cluster that you have, right? Apart from default namespaces. And we also know switch between the namespaces, and we do bundle the resources in a particular namespace that we have in a existing cluster, correct? Correct, right?
Yes, sir.
Okay. Now I'll give an example of a basic YAML of external name. Okay. So I'm gonna write API version space v1. I'll keep it as v1 because it should be a v1 only. Then kind. So what we are creating here, service, right? Correct, right? And metadata. So under metadata, I'll give it here. So just the name of the application. Okay, my external, because my external service. Okay, now under metadata, I'm gonna write my service name. Okay, now the fourth parameter that we have, spec, correct? So under spec we do have type. Okay, so what type it is? The type of the service that we're gonna use in Kubernetes cluster, which is external name. Sorry, there should not be a space whenever you're using any of the services in Kubernetes. Okay, now the external name colon, we use API. Just an example, that external hyphen service.com. So this is what the external name, the domain that we use to expose our application for your application that you have. You getting my point here? So this is the domain. This we use to expose our application from inside the cluster to outside the cluster using the Kubernetes DNS. What is the Kubernetes DNS now? Currently is this. This is the DNS. Through this, we are making use of kind of service. And see, if you are able to access your WhatsApp web in your web for WhatsApp web app through that external name only. So suppose if you're accessing your WhatsApp application in a web due to this external name configuration only, that's how they will be having the Meta, right? The company called Meta, which owns the WhatsApp, that they have the Kubernetes exposed application through the web. They will be having the dedicated domains to build application, kind of WhatsApp, Instagram, and any maybe Facebook, any application. So they will be having the exposed application from inside the cluster to outside the cluster. So that's how they'll make use of the Kubernetes services to expose it. You getting my point?
Yes, sir.
Yes, Dilip.
Okay, just a minute. And I'm gonna write the simple YAML file for service. So here already I have given this is an example of external name with the DNS. Okay, now I'll give a complete the YAML, just an example, and we will build the service, and we list the services, and we do debug the service in further session. Okay, so now I'm gonna write the simple service to create from YAML configuration. Okay, so as I said, we know the YAML format, right? The very first we have to use is API version. So whatever the configuration that you have, you can write that starts from API version, that is v1, and kind we want to mention as kind. See here we do have two YAML that we gonna integrate in a single file. Okay, the top portion is for pod and the bottom portion is for service. Okay, so I'll write it here, and if you guys have any question you can ask. Okay, the very first I'm gonna write it as the pod configuration. for that particular pod only, we'll have to create a service, right? So to create a service, we should have the pod created first, right? That's why I'm going to use a kind as pod. Let's keep it here. Example here. Then it will be easy to write. Okay. The kind as pod, and under metadata, so I'm going to write it as name nginx, because this is what we created, right? And spec, under spec, okay, to a space containers, right? And under containers, I'm gonna write the container name, space container name, that is nginx, right? So, and the image would be nginx. There should not be a space here, and the image for this container nginx 1.14.2, right? And also the ports, okay, and start from the two space ports hyphen container port, right? Container port, that is 80. Okay, so this is related to the pod spec, correct? Correct, right? Now we also use for this pod, how do we create a service? To create a service, we use hyphen three hyphens. We start with three hyphen, and this will divide the pod spec and the service spec. See, this complete in the same file. Okay, now I'll start writing a service configuration. Okay, so I'm gonna write again API service, API version. Okay, sorry, API version, that is v1, right? And here I'm gonna write kind as what? Service, right? And under metadata, I'm gonna write it as the same, because under metadata we have to write which pod that you're creating a service, correct? Currently we are creating a service for nginx, right? If that is the case, what is your metadata should be nginx service, correct? So your metadata name should be nginx service only now when you're creating uh, nginx as a pod. For that particular pod only we're creating a service, right? Similarly under spec, so here under spec, what we need to write under spec? See here under spec, the pod configuration, you are defining your container name, and then image name and the port number, correct? When you are configuring, when you're writing a AML for service under spec, you need to write it as type of what? Type of what? Cluster IP. We use cluster IP as a type. Okay, so type as cluster IP. Either you can use cluster IP, okay? Either you can use type as cluster IP, or the node port, or the load balancer, or the external name. So here only we're gonna write type as service type as cluster IP, and here we have to define selector. Okay, so what is this selectors? Okay, this selector defines the Kubernetes DNS, which exposes the Kubernetes DNS to expose our application from inside the cluster to outside the cluster. That's why we have to define our selector, right? So the selector looks like this: app dot kubernetes.io/name. So from this, when we define the selector, which helps to expose our application from inside the cluster to outside the cluster. Okay, so this is basically the DNS. Okay, and then my app. Okay, and here we're gonna use, okay, this should come here, colon my app. Okay, through this selector, it helps to the application which is my app through this DNS, which is Kubernetes DNS, which helps to expose. So cluster IP is basically default service in Kubernetes, which exposes the services to an external IP. This makes the service accessible within the cluster. Okay, cluster IP, which helps to access the application within the cluster, and the node port, load balancer, and external name, all three are used to expose our application from inside the cluster to outside the cluster through the node port, through the load balancer, through the external name, which is the website from this. Okay, you're getting my point. So that's how we make use of, we have to write the YAML configuration to expose our application this way. Okay, so when we define selector, this helps to, this is from the Kubernetes DNS /name. This helps to expose our application from cluster to the web. Means your browser, right? Through this only it will work. Okay, now I'm gonna write port. So where is the selector? Ports, and hyphen port colon 80, and the target port. Okay, and then target port should be 80. Let's keep it as same, be 80. Okay, so now, so this both, let's make this way just to show you. See, this both configuration we used to write when you are creating a service. As I said, the top portion of the YAML is related to pod, and the bottom portion of your YAML related to your services. Okay, let's remove this space. Okay, so that's how we're gonna write our YAML configuration to write your, to create your services. Okay, see, you need to remember each and every point. You need to create a pod. For the created pod, you will have to write a YAML configuration to create your services. See, instead of this, you can also use cluster IP type as node port. Okay, similarly, instead of your node port, you can also have your service type as load balancer. Okay, similarly, instead of load balancer, you can also use your type as external name, right? External name as type, correct, right? So this is how we create a services by writing a YAML configuration. This is what we have to learn from all the Kubernetes concepts. So that's how we have the Kubernetes features, right? So once we return this YAML configuration, we will be having the command to build this service, to create a service. So that is that is to create service. Okay, so the command that is kubectl okay, kubectl apply -f what service dot YAML. So whatever the pods, whatever the deployment that you created now till now, similarly you can create the service dot YAML file this way, and you can run this command, okay, to create a services. So as soon as you run, you will see the service has been created in the so on namespace, right? Similarly, to know the service which is created with that is kubectl get svc, or you can use services directly. Okay, svc or services. Similarly, to check the logs, you can make use of the command kubectl describe svc. So I'm gonna start using svc for services. Okay, now once you create a service, to get all the pod which is tagged to that particular service, to use to run, to get those pods which is mapped to that particular service, we use kubectl get pods -o wide. This is the command we use. -o wide. -o represents output in a wide format. O represents output. Okay, in a wide format. Okay, similarly, you can also list the deployment once you create your services. Okay, so how do we do? kubectl get deployments -o wide. Okay, you can also see the deployments pods in terms of output will be a wide format. Okay, you can run this in your cluster. Okay, similarly, we can also see the services in a wide format. So kubectl get svc -o wide. Okay, so you can try these commands to see the output. Okay, so as of now, my cluster is like down, so I'll have to make use of work first, then we'll create a service. So before that, I'll have to give some theoretical concept to understand the service types and the uh, services that we're going to use in Kubernetes cluster with an example. So this is what we're going to write the YAML configuration. The top portion is the pod, and the bottom portion is the service that we're going to use in Kubernetes cluster. And these are all the commands that we're going to write, uh, that we're going to run in the cluster to get the output based on your configuration. Okay, see, as I said, here we're going to use lot of commands, lot of configuration, lot of YAML files, lot of concepts. Okay, you need to learn this today only. Okay, so that's how it works. Then only it will fix in your mind. Okay, now let's have a questions. Now, anybody has any questions? And Rakshita, you can use the external service types as the very first letter capital and the second also a capital.
Yes, sir. But there is no
Either
space
capital
between
or
them, sir.
yes, there is no space. That's
There
what I
is no
said.
space.
If it is not working, move it to lowercase. That's it. It's not a matter of either lowercase or, but sometimes it may matter also. So either we'll explore more on when we start working hands-on. We do have to create a service, and we do have to run these commands to get service, and we should understand the services logs, and these are all we'll have to run the command. So if you guys are able to access your cluster still, then you can create a simple service, and you can create a service by applying it and run svc describe get pods -o deployments -o and svc -o to see the output in a wide range. Wide range in the sense it gives an IP, that's it. External IP if it is created, and then if it is created with a node port, it gives a node and the port. Through that we can able to access the application that we gonna check using -o wide command. Till here is same, right? Get pods is same, get deployments is same, get svc is same. For that command we are making an output with a wide range, that's it. -o wide. Anybody has any questions, guys?
Yeah, Sandeep, the port for the service and the pods, it should be same when
Service?
you,
No. Wait. Service and the pods that you're asking, right?
yeah. So
Okay.
we used container port 80 in line number
Mm,
206
mm,
and 218 also or 217 we use
mm,
port 80.
mm.
So these ports should be same or
Yeah. This should be same. Either when we have the ports available, because normally we use the ports are same. Why? Because we will not get any downtime when we deviate the port here. So it looks for
Mhm.
this container port in the target port 8080, then we will not be having, it will not get confused in the when it is looking for the configuration. When we write apply kubectl apply -f service.yml, better to keep it same. And when we have the dedicated port, which we got to know from the network team or the architecture, we can define the same, but we'll keep it same.
Okay. And for the type, when
Hmm,
cluster IP was given,
hmm.
and the selector is app.kubernetes IO or whatever, right? So
Okay.
you said this is the DNS name now. This serves as a DNS name, right?
Yes. Through this,
So
through
yeah,
go ahead.
through this we can access the service that we are running.
Yes,
So
correct.
like we do Jenkins, right?
Hmm,
For example, www.jenkins.com or whatever. In
correct.
the same way, like we just use whatever we
Exactly.
give here.
Yes. Jenkins with your version 2.456.9. Sorry, it should be dot. The version that we're gonna use. But
So
if
if
we
we
are
give like this, whatever we give Jenkins 2456.8,
hmm,
what should be the address that we need to use? Is it
see,
from app.kubernetes.io/name and whole thing, or only the
no.
Jenkins 2456.8?
Okay. So this is an Kubernetes API. This helps to connect to this DNS
Sorry,
that we
my voice is
purchased.
breaking. Hello?
Yeah, you are audible, Arun. Arun, I'm audible to you.
Yes, sir, you're audible.
Okay, I think the issue with Arun's only. Arun, are you there? Okay, I'll let him back then.
Sorry, Sandeep, can you hear me now? There was an
You
internet
are
connection issue.
audible. Yeah, you are audible. I'm audible now.
Yes.
Okay. So here under selector, I have written app.kubernetes.io. This is the Kubernetes DNS, which helps to connect to this domain that we purchased from DNS. See, Kubernetes DNS is different, and the actual DNS that we purchased, that is different. Now we use this DNS from Kubernetes to connect to this application that we built /app.
Okay.
Okay.
Mm-hmm.
Now it connects to this DNS instance that we purchase. Suppose, for
Mm-hmm.
example, www dot. Actually, the DNS name should not be like this, right? It should
Right.
be
Yeah.
www dot. Say, suppose if you are working in IDC some company dot jenkins.com, correct?
Correct.
This
Yeah.
is how we have to access our application. To
Mm-hmm.
access this application, Kubernetes helps to connect Kubernetes DNS to this application as a service called Jenkins. As a service called external name to the application of, instead of here, if you point Jenkins as an application, it should be written here as Jenkins currently.
Okay.
So that's how it works. And this connects to the DNS, the actual DNS that we purchase from the DNS community. Through that we can access. Suppose if this website is down, we gonna check in this YAML configuration only.
Okay. Yeah.
Getting it? Now
Yeah.
some of
Yes.
the government websites are maybe down sometimes, and they'll say like server down through this configuration only. Because we should understand what is the issue and where they are fixing. If the website is down or if the server is down, if they are saying something like server is down, so what they have the backend configuration is this only. If they have Kubernetes inbuilt.
And some people see before Kubernetes, how they're accessing our application through the DNS only, that without connecting with Kubernetes DNS with internally. Now they are connecting Kubernetes DNS to the actual DNS website that they purchased. That's it.
Okay.
So that's how
And
it works.
also you mentioned when we use type as external name
Hmm.
without using the IP or port, something you mentioned, which is
Correct.
very much important.
Yes.
Right?
Yes. No
So
proxy.
when
Hmm.
no proxy, yeah.
Yes.
How would the YAML file look in this case? Type is external name and
When
selector we still give.
yes, that's why we use selector as Kubernetes DNS internally within the cluster. So here we will not write any proxy. We will not write. We will not use any IP. Directly, it picks the selector. This is the inbuilt Kubernetes DNS. Through this, it connects to it tagged to the application. From that, it connects to the DNS. That's how the internal mechanism from the service. So here we will not use any proxy. Suppose if you wanted to connect to that any database, Postgres or maybe SQL, right? So,
Mhm.
so that we will not be having any proxy when we use external name. Say suppose when you built your database website through the external name as service type, we will not be having any proxy. Directly it
No.
will connect when we point this. We can also have the multiple selectors here instead of one. We can have multiple selector. Instead of that, we can have the database as the selector name. We can point here. Through that, we are avoiding creating a proxy to connect to the database when we have the database website that we created. And we will not be pointing any port here under the YAML configuration. Is that clear?
Yeah, yeah. So you said we can write many selectors in one service, right?
Yes, yes. You can point many selectors. See, selector nothing, but it picks that. Picks in the sense, in this case, it will pick the Kubernetes DNS to expose this application, simple. To connect to the DNS.
Hmm. Okay.
Yeah. Anybody has any questions again? Any doubts, guys? Guys, I'm asking you.
No questions.
Okay.
Sandeep,
Hmm.
now currently, if the one node is down, so again, like we can make another node automatically to the up, right? Like,
Yes, we can do that. That's what we should not have the downtime.
so now, like we'll be having the multiple nodes in that. So, like how that link to the services now we create.
See, this services, whatever that you're creating, you will create in the node itself. Inside the node, you will create your pod. Inside the node, you will create your services.
Yeah.
That's how it works. See, this when you're creating services external name, this will create inside your node only. When your node down, complete your pod, your service, your deployment gone case.
Okay.
Yeah, that's how it works. Clear?
And
Bari
Sandeep,
Sagar.
is there any maximum number of nodes that we can create in a cluster or in
No.
namespace?
Yeah. But yeah, that depends on the storage that we have. So there is no limit, like we will be having a limit based on our storage. Say suppose when we have cluster, the cluster itself is having some 10 GB. Inside that we'll divide, say suppose each node can have 1 GB, we can create 10 nodes, right? Suppose when you have a 2 TB of cluster memory, we can have each node can sustain 10 GB. We can have a 10 nodes, right? That's how we can divide the memory. So basically, and whenever we are creating a memory, we define each node contain 10 GB. That's how we write the YAML configuration inside the YAML configuration to divide the memory. So that's how we can create a node. For maximum creation, that depends on the memory complete total memory that we have.
we can select we can write based on the total memory.
Okay.
Yes. Yes.
Sandeep,
Hmm.
one more. Here in the services, I wanted to access multiple pods.
Hmm.
So in the name section, I can add, like example, now the name is Jenkins.
Hmm.
So I wanted to add for Nginx. So
Hmm.
in the next line only I can add, it will take the Nginx pod details.
No. See it will get confused because see whenever you are it is related to the service or it is related to the pod.
It is services only.
Okay.
See, in each pod, we will not create the services, right?
Hmm.
One service can access multiple pods, right?
One service can access multiple pods means yes, correct.
So, in the
Hmm.
service section only, we will mention what are all the pods has to take from this service.
Okay. Wait, basically, when we are creating a service, we will write this both upper portion and the bottom portion. Okay. Now, let's say we have this pod that we are creating is Nginx.
Hmm.
Okay. Or Jenkins. Let's take in Jenkins. You are creating a pod as Jenkins, right?
Yes.
For this pod, we are creating a service of Jenkins. Okay.
Hmm.
Jenkins hyphen service. Okay, you're creating a pod for that particular pod. You're creating a service as Jenkins. Why you're creating service as Jenkins? To access your Jenkins to the web from inside the cluster to the outside the cluster to make use of this Jenkins in web. Correct?
Yes.
So that's how it works. But now, if your case, we cannot write the different service instead of Jenkins. This will not gonna work out. This will not work because we should be have as soon as you create a pod as Jenkins, you should have the service to be created for Jenkins only, not on any other pods or any other service. Because the motivation here, the intention here is to create a service to expose our application as Jenkins to access my Jenkins application as a website in browser, right?
Hmm.
So when you are seeing, okay, say suppose, so when you are using your any application here, say suppose WhatsApp like this, right? So the web here you can see the first tab, right? So
Yes.
that until your cluster works backend, so your website, you are able to see your application. So if you are able to see 24/7 365 days, this works backend this code only. Is it clear?
Okay. I mean, for each pod, we have to write a different services.
Yes,
Okay.
for each pod, in the sense for Jenkins pod.
Yes.
Correct. Yes. Suppose if you want to create Nginx application, you will have to create your Nginx service here. And suppose if you want to have Tomcat pod to be created, and you will have to write a Tomcat service here. That depends on the application that you configured.
Okay.
So in that case, the pods and the service are one-to-one connection, right? I
That's
mean,
how
we
we do.
can't have.
Yes.
Okay. Okay.
That's how we do have the expose our application to the external website. That's why. So as soon as we create a pod, for that particular pod, we'll have to write the service here. Clear?
Yes.
So the intention here is whatever the pod that we create, that particular pod, to expose it to the web, we'll write a service configuration.
And Sandeep, in one pod, we can have multiple containers, right?
Yes, you can have.
How we, I mean, currently in industry, how do we use it? Is it like isolated, like one pod, one container, or
No,
one
no, no,
pod
no.
with multiple containers also we use?
Yeah. So basically that depends on, see, the first question, we can have multiple container in each pod. Okay.
Okay.
And the second point,
all the container which they are tagged with the label. Say suppose when we have multiple container, we tag it in a different labels, and that label, say suppose when we have our application nginx slash, the very first application is payment, any payment, right? And the second one, I'm gonna write as name in the nginx application, order placed when you're in a payment app like Flipkart and Amazon, maybe any shopping websites, right? The very first pod should look for a payment, the customer which is having the payment which is done. That pod is the container looks for the payment configuration only, and the second it go for the order placed. Once the payment done, that should go to the order placement, correct? This is the case when we divide the load, we use the multiple container here in the pod, but we will not write under metadata multiple pod. I'm just saying we have to divide that configuration in the same YAML. You getting my point?
Yes, got it. Yeah.
Yeah. So similarly, say suppose Flipkart slash payment, this looks for one pod. Similarly, when we have the other RT, okay, the other, so once the payment done, it should order placed, right? Order to be placed. So the first container looks for payment and the second container looks for the order placement, right? So that's how we can use the container, the multiple container in each pod. So that's how we are dividing a load to get a immediate response. The best practice that we do. Okay. Again, anybody has any questions? If not, we'll wind up the session. I'll have to have some other activity to do. We'll continue from tomorrow. We'll write a simple YAML again. We'll create a service. So we'll explore more on this. Okay. Clear?
Sir, if
Yes,
there
sir.
are a lot more services we do have to create, then how can we remember all the ports on we want to expose? Is there any way to automate this process?
Service creation.
Yes, sir.
This is the way we do automate. Create a service. 1 minute. Just a minute. See, this is the way we do automate the service creation. Okay. So you're asking about the port.
Yes, sir.
See, basically, how do we select a port? If the port is available, we do select it. If the port is busy,
Then we have to open the file and we have to.
yes. Before exposing, we'll have to check on this.
Okay.
So when it comes to the automation part, this is the way we do create an automation. The YAML coding, the YAML format.
Okay.
Okay, guys, let's connect tomorrow. Okay, thank you. Bye bye.
Thank you, sir.